Hi, our presentation is Drifting Toward a Sustainable Future, How Density Can Affect the Spray Drift of Pesticide Application. My name's Paige and I use she, her pronouns.
My name's Cleo and I use she, her pronouns.
My name's Morgan and I use she, her pronouns.
My name is Henry and I use he, him pronouns. So in our case study, we plan on analyzing the effect of a pesticide's density on its spray drift distance. We predict that there will be a negative correlation between the two variables, thus lower densities will travel farther. From our results, we found a significant negative correlation for motionless conditions and some insignificant and varying correlations in windy conditions. We can conclude that density is a significant factor in a motionless environment, but density is not as significant in a windy environment. Our hopes with improving our understanding of spray drift is to inform policies and pesticide regulations that would in turn reduce drift and pollution.
You may be wondering why pesticides are of such concern to us. They are necessary for agriculture development, however, they can have environmental, health related, and economic consequences to all organisms. One catastrophe caused by spray drift was with pesticide called dicambia that impacted millions of acres of soybean farmland. Current research on spray drift looks to maximize droplet size because larger droplets have a greater downward velocity and are less likely to evaporate. But studies only indicate density as a factor without an explanation of the mechanisms why. So with our controlled experiment, we hope to shine light on the relationship between density and spray drift distance.
So for our experiment design, we wanted to look at the effect of density and wind speed on the distance of spray drift. And in order to do this, we created different solutions that mimicked common pesticides. We made the solutions at certain densities using salt and water and sprayed them over a white piece of paper, recorded the spray drift distance, the longest droplet, and repeated the process at several different fan speeds to mimic wind. After recording the data, we created graphs and analyzed the data with the chi-square test.
The two graphs shown here in our results section are representative of the data in the two parts of our experiment. The graph on the left represents the negative correlation between density and maximum spray drift with no wind speed, and the graph on the right represents the potential and varied correlations between density and maximum spray drift at different wind speeds. When we performed the chi-square test on the data, our findings were that the negative correlation for no wind speed was significant, while the varied correlations for various wind speeds were insignificant. Thus, we can only determine a relation between density and spray drift in windless conditions.
From our data, we can conclude that the density of pesticides influences the distance of spray drift. Wind speed does affect the distance of spray drift, and while we believe density may still be a relevant factor in wind speed, our evidence does not allow us to fully accept the null hypothesis, though we also can't reject it based on our data. Unfortunately, we couldn't use two of our solutions because the water was at its maximum salinity. There was potential error in our data because of the spray bottle's poor quality. In the future, we would purchase higher quality spray bottles and use a different solvent to achieve more dense solutions. Our data is applicable to regulations regarding land conservation and proximity to human populations. The EPA, which is the main organization for pesticide regulation in the US, has national pesticide regulations, and some states, such as California, have their own regulations in place as well. The lack of strict regulations allows pesticides to leach into the environment and leads to health issues in human populations, such as the picture in the lower right of the injured hands and feet, and mutations in wildlife, such as the picture in the upper right of the frog with multiple legs. Thank you all for listening to our presentation today, and please feel free to reach out with any questions.